Let's prepare on 3 moments theorem. So today we are going to see about this 3 moment theorem. Okay, so this is used when the structure has at least 2 spans. Okay, so 2 spans like a continuous beam should be there. If it has single span or 3 span also, it has to be converted such that you should adopt that structure into this moment of 3 moment theorem. Okay, so we'll see that also in the next thing, but in general it is explained as it should have a minimum of 2 spans. Okay, and then it is used only for indeterminate structures. You can't use this method for determinate analysis. So here an example is given. So this is a continuous beam with 2 span. Okay, so here first what you should do is you should draw the free bending moment diagram. Okay, free bending moment diagram means it is for each span. Okay, you should not join the whole structure and draw a combined bending moment diagram. So you should draw the bending moment for each span separately. So here it is a simply supported UDL. If you see the first span means simply supported UDL. So I have drawn just a UDL shape here. That is a parabola shape will be coming. And for next case also it is a parabola. So the value for the parabola is, we know that it's WL square by 8. Okay. So now these two values you should take from here. One is x and another one is a. Okay, so this x is what means it is the center of gravity of that free body diagram, that is the free bending moment diagram. So centroid means in here obviously it will be the center of that, but you should measure the distance from the ends. So here it is from this end and here it is from this end. Okay, a means it is the area. So to calculate the area of a parabola shape, it is 2 by 3 into its width into its height. Okay, so here it's 2 by 3 into L1, because here the length is L1 and here it is L2. So if you take this case means it's L1 into W1 L1 square by 8. In the second case it is L2 into W2 L2 square by 8. So now we have got x1, x2 and a1, a2. So with this values only we are going to apply in the formula so that we can find the moment. So this is the formula used. Okay, so don't just get afraid by seeing this long formula. It's very simple only. So we have three support reactions there, no, A, B, C. So just remember that alone. So the first formula is MA into L1 by I1. Okay, and the second factor is 2 MB into L1 by I1 plus L2 by I2, and the third factor is MC into L2 by I2. Okay, so which is equal to 6 A1 X1 bar by L1 I1 plus 6 A2 X2 bar L2 I2. So this is the simple formula we have. So how we are going to solve this formula? So that is the case here. Okay, so what is the single trick we are going to use here is, we have considered it is as a simply supported beam. Okay, so we know that for a simply supported beam the moment at its end is 0. Okay, so we know that already. So we are going to apply that only here, because we are considering a whole continuous span beam where A and C are the extreme ends. So obviously at A and at C the moment will be 0. Okay, so this term whole will become 0 and this term whole will become 0. These all values we have. Okay, so we can equate this formula with this one. So the only unknown here is MB. So you can calculate the MB value, that is at the B point. You can calculate the moment. After calculating that moment, you can draw the combined bending moment diagram for the whole structure. So this is how we want to find the moment at any point using this 3 moments theorem. Okay, so the same thing now we are going to see for a 3 span beam. So in the case of this 3 span beam, here I have taken A, B, C, D. Okay, so here first you consider this span alone. So just hide your CD part. So the same procedure which we done before, no, so that has to be applied here. So consider AB span and BC span. So here we know that moment at A is equal to 0. Okay, because it is at its extreme end. So at that end moment is 0. So we will be getting the equation in terms of MB and MC and all the right side terms now, that is 6A1 X1 I1 L1, everything we have the value. They will be giving that in the question. So that is all we will be having, the like known values only will be given. So only unknown will be MB and MC. So keep this as first equation. Okay, so now the next step is to hide this part. AB part you just hide it. Now consider BCD and follow the same procedure which we did it before. So considering BC as one span and CD as one span, you will be drawing the diagram, bending moment, and you will be calculating area, x1, everything, and then you will be applying in the formula. So here also you will be getting a equation with MB, MC and MD also. So here apply MD is equal to 0 because it is at its extreme end. So now also you will be getting another equation with this MB and MC. So now you have two equations with two unknowns. So this is enough for solving that. So you'll be getting the value of moment at B and C. So that's all, the problem is over. So now the same thing is given for a fixed end beam. Okay, in the previous cases it is all about simply supported, so we just applied moment at the end is equal to 0 and did that. But in fixed beams we can't do that because in fixed beams moment values will be there. So here what we are going to do is we are going to consider a imaginary span to the left of that cantilever or that fixed support. Okay, so if there is a fixed support at both the ends, means you have to consider in both the sides. Okay, so here it is in one side only, so you have to extend that with the imaginary line just like a simply supported beam. So in the red color line I have drawn now, so I have just drawn that and I have named it as A dash. So again we have to follow the same procedure which we did before. Okay, so here if you see means I have considered the span A dash A and AB. So with that you will be giving an equation. In that you can apply MA dash is equal to 0. So the equation will be in the form of MA and MB alone. And in the next you have to take the span ABC. So you can apply C is equal to 0 because it is at a simply supported end only. So you can apply C is equal to 0. So now also you'll be getting another equation with MA and MB. So you're getting two equations and two unknowns. So here you can apply the equations and you can find the MA and MB value. Okay, so when you apply A dash no, so at that time this is important. EI value is infinity, L1 is 0 and A1 is also 0 because it is all an imaginary line. Okay, so when you consider it as imaginary, you have to apply everything 0 only. Obviously we are going to take that end as a simply supported and the whole term we are going to consider 0 only, but this is also to be noted. And the last case is single span beam. Okay, so if a single span indeterminate beams comes, what can we do? We can consider the imaginary line both in the left and right of that beam. Okay, so here a fixed beam is given and I have considered the simply supported like a beam in the left and also in the right, and we are going to follow the same procedure. So we will be considering A dash A B, that span alone first time, and we will be getting moment at A and moment at B in the equation. And when you consider A B B by A B B dash span, you will be getting again the equation with MA and MB. So when you solve these two equations, you will be getting the values of MA and MB. Okay, here also for the imaginary points, that is A dash and B dash, you have to apply 0 because we are considering that as a simply supported ends. So this is all about your moments, that is 3 moments theorem. Thank you and keep watching for the next lecture on flexibility matrix method.